Hello everyone, welcome back. Today we will cover a very important concept in Java multithreading. Today's topic is synchronization using synchronized keyword. In case you have missed any of the previous videos, please check it out from the playlist link given in the description. Also, if you want to access any specific section of the video, like you want to skip some initial discussion part, then you can access the implementation chapter from the chapter list given below. Now, without any further delay, let's start. Synchronization in Java is like a way to make sure that multiple threads do not interfere with each other when they are working with shared resources or shared data. It's like when two persons are speaking, then we need to make sure that they do not talk over each other when having the conversation. First, let's try to understand why synchronization is needed. I will try to explain this concept with a very simple example. Suppose you have a website and you want to capture the number of visitors or the number of hits as a counter in your application. Different threads are created for different users when they are trying to access your website, and once they access the pages, then they should be updating the counter value. So the counter will act as a shared resource between multiple user threads. Now let us code and see how this basic implementation looks like. Now let's start with the counter class. It contains a single instance variable counter which will store the number of visitors to your website pages. We also have a couple of methods in this class. One is increment, and as its name suggests, this method is used to increment the value of counter variable. Then we have getCount method which simply returns the current value of counter. Now let's move to the second class which we have created, which is a kind of our service class, which is CounterUpdater. This class extends the thread class and also overridden the run method so that the multiple threads can update the counter value in a non-blocking way. In CounterUpdater, we have an instance variable of type counter and its value is set up using the constructor of CounterUpdater. In the run method, we are running a for loop 1000 times and calling the increment method of counter. So by this logic, the value of counter should be increased 1000 per thread. That is, if one counter updater thread is executed, then the counter variable value should be 1000 by end of that for loop. And if two threads are running, then the value should be 2000. Now finally, let's look at the client side code as well. Here in the main method, we are creating an object of counter first and then two different threads T1 and T2 of CounterUpdater. After that, both the threads are started and we need both the threads to complete their execution before we print the final count value. So to achieve that, we have used thread.join method call here so that only the control of main thread can proceed further once both of these threads executed completely. And in the end, we are printing the final count value using getCount method of the counter class. So as per our discussion, we are expecting the final count value to be 2000. Now let us execute this code and observe the output. So here you can see the final count value is coming at 1511. So this is also not a consistent value. So let me try it again and see whether it is changing any value or not. So if we run it again, then we will be able to see a different value. So here again we can see 1638. So why this incorrect value and every time changing value is there? So what is the reason for this incorrect output? The main reason is lack of synchronization between the threads. Now suppose in the beginning thread T1 started executing the increment counter code and updated the value from 0 to 1, and still T1 is being executed by CPU, and it again started incrementing the value. But if you see, incrementing operation is a collection of more than one operation. First counter variable value will be read, then one will be added in the current value, and in the end the updated value will be stored back in the counter variable. So when the second time T1 thread started executing the increment code, the first step was completed, that is, it has read the counter value which was 1 for the counter variable, but at the same time context switch happened. So what exactly is context switch? This term is associated with execution and scheduling. When multiple threads or processes are running in a system, then CPU time is shared across those running threads or processes. Now, how that time is divided among those threads is totally dependent on how the CPU task scheduler is implemented. But one thing is clear, that single thread will not keep using CPU. So once CPU is changing from one thread to another thread for execution, it will store the currently executing thread related state, so that when it has to resume again, the state should not be lost. And to start executing another thread, it will read the saved state and start executing. The whole process is known as context switching. The context of CPU is switched from one thread to another thread for execution. Now I hope this context switching concept is clear. Please let me know if you want, I can try to cover up different operating system concepts related to multi-threading as well. Now back to our problem. So due to the context switching and the lack of synchronization, many increment operations were lost. This is mainly because one thread read the value before the other thread was able to update it back. So T1 read the value 1, then context switch happened. At that point itself, T2 also read the value of counter as 1. But by end of execution of those two, T1 and T2, T1 will increment it to 2 and the T2 will also increment it to 2. But actually what was supposed to happen, the T2 should increase it to 2 and the T1 should increase it to 3. So in that case, one counter value is lost there. So how this problem can be solved? To solve this particular type of problem, we can use synchronized keyword. Now synchronized keyword can be used in two ways. One is we can declare a method synchronized, and when any method is declared synchronized, then at a given point of time, a single thread can acquire the lock to execute code inside that method. That means if we declare this increment method as synchronized, then once T1 enters or T1 starts executing this method, the T2 will have to wait until T1 finishes the execution of this particular method. Now let us try to fix it using the synchronized method quickly and observe the output. So I have just added a synchronized keyword in the method signature itself. Now let's try to execute this code again. So here you can see the final count value is 2000. Let me try to execute it one more time just to make sure that everything is working fine. So here you can see every time now we will run, the final count will be 2000. Why? Because we have synchronized this particular method. So once one thread is executing this method, the other thread will not be able to enter inside this method. So that dirty read of old data will not be there and everything will be synchronized. Here you can see the issue is now fixed. There is one more way to synchronize critical code execution using synchronized keyword. The second way is to use synchronized blocks. In this way, the whole method is not synchronized, but a particular part of the code known as critical section is added inside a synchronized block. Now let me fix the code quickly by making a critical code section which is counter plus plus inside the increment function as a synchronized block. Now I have added a synchronized block here, and this represents for the same particular object, the different threads will not be able to access this particular resource. So let me just execute it. So here you can see the issue is fixed using synchronized blocks as well. So now the question is, which one is better, synchronized method or synchronized block? And when to use which approach? Use synchronized method when you want to synchronize access to an object's entire state, as they log the entire object. This can lead to the decreased concurrency and potentially slower performance if many threads are trying to access the object simultaneously. Use synchronized block when you need fine-grained control over synchronization. The synchronized blocks can potentially be more efficient than synchronized methods as they limit the scope of locking. This can result in better concurrency and performance in the scenarios where only specific part of the code is synchronized. So suppose in this particular increment method there are multiple number of lines. So in that case, if we use synchronized method, the whole code execution will be locked. But if we can only synchronize the critical section of the code under synchronized block, then the remaining lines of code will be available for multiple threads to execute. That also increase the concurrency and performance. It is important to use synchronization carefully because excessive synchronization can lead to performance bottlenecks. In Java, you have alternative synchronization mechanisms available in java.util.concurrent package, such as reentrant lock as well, which can offer more control and performance optimization compared to this traditional synchronized blocks or methods. So that was it for synchronization. In the next video, I'll try to come up with some more interesting concept from the multithreading. Thank you so much for watching this video. If you find it useful, please don't forget to give us a like. See you in the next video. Till then, keep learning.